So, hello everybody, my name is Artur Signell. I'm working as head of R&D at Vaadin. Talking today about how to make client-server hybrid applications, and especially how you can do this with Vaadin. So, what does this really mean? Well, before we get into that, let's look at some cars. What do we have here? It's a Mercedes. It's a nice car. Sure, I could have one. Nothing special about it, or, well, depends on how you look at it. So let's just look at another car. What do we have here? It's a Tesla, yeah. So how does this differ from the Mercedes? Yeah, it's electric. It has the same four wheels and everything, but it's electric, yeah. The Mercedes runs on gas. So let's look at the third car. What do we have here? Yeah, a BMW i8. And, well, what's a BMW i8? It's a hybrid car. So it actually runs both on electricity and on gas, depending on where you are, how you drive, and what you need, so it can adapt. If you look at the cars from a different point of view, we have a Mercedes. It's not a very cheap car to drive. It uses quite a lot of gas because it's quite a big car. So if you look at the Finnish gas prices, you would pay something like 13 euros per 100 kilometer when driving this car, which is quite a lot. But otherwise it's a nice car. It has a long range, over 500 kilometers. You can basically go anywhere you want. You can go to the whole of Europe if you want, because there are gas stations everywhere. You just go 400, 500 kilometers, fill up the tank, and then you continue. Really nice. If you look at the Tesla, on the other hand, it's much cheaper to drive. You can go get as low as €1 per 100 kilometers. It has roughly the same range as the Mercedes, but there's one huge difference here. You need to find somewhere to charge the Tesla if you're going across Europe. And where can you find that? Well, certainly not in any place where you can find a gas station. So you're a bit more limited. Even though it's much cheaper to drive the Tesla, you're a bit more limited in where you can go. Now, if you look at the BMW hybrid, it kind of combines these two things. It's much cheaper to drive this than driving the Mercedes. The range is roughly the same, and you have the same benefits as the Mercedes, that you have gas stations you can use. So you can go across Europe without any problems. So, why am I talking about cars? Well, we'll get back to that. Let's talk about some web applications in between. So when you do a web application, you typically have these layers in your web application. You have your backend server, database, something, and then you have your web server where you would store all the files that goes to the client, HTML, JavaScript, and so on. This serves them to the client then. On the other hand, you have the JavaScript, which the client actually uses, and then you have communication between these. So if we're talking about the client-side UI, we're talking about basically these three layers, because you implement something in the client, something on the server, and how they communicate with each other. If you're talking about the server-side UI, we're basically talking about only this layer, because with server-side, you code on the web server, and then you get the communication and JavaScript for free because the framework takes care of this for you. If we look at this from a different point of view, if you're doing a JavaScript application, you will typically or always implement all these layers. Well, okay, of course, whatever you do, you need the backend, so you always have the backend you need to implement. But if you do JavaScript, you will implement something on the server REST API something, the communication, and then the JavaScript that consumes the services. Now if you use GWT, you have another option. Instead of writing the client side in JavaScript, you can use the Java to JavaScript compiler. Actually, you will use it, because why would you use GWT otherwise? But you still have the option to use JavaScript if you like. We have seen talks about how to improving the interop between GWT and JavaScript here. So you can go there if you like, you don't have to. So, well, this is basically, and again, the client-side UI. You have these layers that you're staying on. Now, if you look at Vaadin, it's kind of a different story, because we're talking about server-side. So yes, you need the same backend server as in all the other options. And you need to implement your UI on the server. But basically all the other layers here are optional. So Vaadin will handle the communication for you, it will handle the client side fully for you, unless you really want to go there. And what does this mean in practice? Well, with Vaadin, you can actually do client-side UIs, or you can do server-side UIs, because you have the option always of going to the client side. But the real benefit here with having only one layer required is basically that if we develop on the server side, we can get away with writing much less code, because we're only working on one layer instead of 3 layers. So I would claim we actually get the development time down by like 50% if we stay on one layer and let somebody else handle all the other layers for us. And similarly, we'll have then less than 50% maintenance to do with, because we have much less code. On the other hand, there are also always good things about doing it on the client side. If we do it in 3 layers, we will have full control of everything that's happening. We can adjust the DOM, we can adjust the communication exactly so it fits our needs. But, well, the downside then, of course, 3 layers. So basically, we can look at this in a way that the server side and the server side programming model, it's optimized for productivity. So you want to get things done and you don't really care about the details. But on the other hand, if you look at the client side, it's more optimized for control so that you can do exactly what you want. You want to care about the details, but it's not as optimized for productivity. So you will spend some more time making the code for the client side. But before I go any further, as this is a GWT conference, I'm not sure everybody here is familiar with Vaadin and how Vaadin works, so let's just do a quick recap on how the server-side UI works and what it really is. So a typical simple Vaadin application could look something like this. If you're familiar with GWT only, you will recognize some similarities. So basically instantiate a text field and a button. Okay, this needs to be added to the layout, which is not shown here. And add a click listener. But the thing is that you have to note that this all is server-side code. So all the listeners, everything, they will be triggered on the server side. So the framework will automatically send any click events from the client to the server and then invoke the event listener on the server. So actually what happens if we start this Vaadin application is much the same things as if we start a GWT application. So you start by downloading some HTML, CSS, maybe images, some JavaScript to the client. In all, it's quite a lot of it, over 1 megabyte. How it differs from a GWT application basically is that the initial HTML, for instance, is generated by Vaadin. You don't write it by hand. So it's just, well, it's just a bootstrapping code to get the application up and running. Of course, you compress these 1.2 megabytes always, so you get down to something like 300 kilobytes. And then, well, for this particular application, we can even reduce it to 135 kilobytes because the full widget set used in Vaadin, it contains a lot of different components, and if you would only use a few of them, we can just drop out the rest of the components. So the UI would then look something like this. We have a name field and a greet button. And the interactions, if we write, well, Jonas is not my name, but if we happen to write Jonas in the field and click on the button, there's just a message going to the server saying that the text Jonas was entered in the field and the button was clicked. So it's a really small message, which then invoke on the server the click listener, which in turn will call then the notification class of Vaadin, which will show a notification to the user. So it will send back just a short message that add a notification on the screen that says, "Hi Jonas." So this way the communication is handled completely by the framework, also the client side. Okay, so let's move on to hybrid applications. But first, let's think for a while why we want to use client side and when we want to use server side. Okay, we talked about the lines of code you have to write, but there are other considerations you should have. So if you want to do an offline application and you try to do it server side, you're going to have a bit of a problem, because server side means you always have a connection to the server, and offline means you never have a connection to the server. So you better do it client side if you want to do offline. Also, of course, when the server-side programming model is such that events go to the server, are handled on the server, and then the result is sent back. So if you want to have real low latency interaction, you need to do this on the client side, so you can skip the communication altogether. And of course, as you have full control on the client side, you can more easily tweak your application to have the really maximum scalability. So if you're making a new Facebook or Twitter, it might make sense to do it on client side. Now on the other hand, on the server side, for me at least, if I have the option, I do it on the server side because it's so much easier. I write so much less code, as mentioned already. But there are other considerations like high security. Your code stays on the server. You can be sure you don't leak the business logic accidentally to some user. As the communication is taken care of by the framework, you don't have to worry about accidentally exposing some data that you thought you didn't expose, and so on. And also you have, of course, on the server side, you have the possibility to use everything basically that Java offers, and every jar available anywhere on the net. So on the client side with GWT, you have quite a lot of stuff you can use, but not everything. So what if we combine these two? Well, of course we want to combine them in such a way that we get the benefits from both sides. It would just be stupid to combine it to get the bad sides. But anyway, however we combine it, we will add some complexity to the equation, because if we do only client side, we only have to worry about client side and how that works. If we do only server side, we only have to worry about how that works. But now, if we combine these two, we actually have to worry about how they both work and how they interact with each other. So before going further again, let me just say a few words about Vaadin and the Vaadin's relation to GWT. Okay, GWT is probably familiar to most of you. The conference, it's up there. That's where we are. But what's the Vaadin's relationship to GWT? Well, previously Vaadin's relationship to GWT was that Vaadin was using GWT to implement widgets on the client side. And this kind of changed when Vaadin 7 came, because with Vaadin 7 we decided to integrate GWT as a part of the framework. This allowed us to, well, mainly fix bugs that affected us before they were fixed and released in the official GWT branch. So we had more control over our client side also. So today it works more like GWT is a part of Vaadin and we're fixing bugs there and contributing them back to GWT instead of using GWT directly as a dependency. What does this mean for hybrid applications? Well, it means we can build the hybrid application completely in Vaadin, and as Vaadin also is based on GWT and the Vaadin client side is using GWT, or the GWT part of Vaadin actually, so we can be sure we don't have any problems now that we start mixing server and client side, because we have all the same versions and so on of everything. So let's have a look at a small demo of a hybrid application. Actually, let's see if the Wi-Fi works. So everybody who's surfing now, please stop. Yeah, it doesn't seem to work that well. Actually have a wired connection here I can test. Okay, this doesn't work exactly as intended. Let's look at it from my local host then. So what do I have here? I have an example of a hybrid application. This is actually an application made with Vaadin TouchKit. It's made as a server-side application. The idea of the application is basically you can write parking tickets, something we all love. So you have a view here where you can write a new ticket. You have the time, the location taken automatically from the phone. You just add then the vehicle ID and the type of violation in the area, and you can take a photo and attach it as well. And you have a save button which will then send the ticket to the server so that somebody else can process it, print the ticket and so on. But down here we also have a few other tabs. You can see, for instance, where the last tickets have been written. You have some table data. You can scroll through who has been working and what shifts and when, and you also have some nice statistics about who has been writing the most tickets and are you in lead or not. Or where the tickets have been written. How is this in hybrid application? Well, it's a bit tricky right now to demonstrate as I'm a local host and it's a bit hard to go offline, but actually it seems to be, my network seems to be offline. So now that I'm using the internet version and I'm offline, I will actually see a slightly different application here. We can see that the 3 tabs down here, they are disabled, so I can no longer visit them because all the data in these tabs are such that I really don't want to download all the data to my device. So they are only available when I'm online. And the reason why this new ticket is available offline is, of course, that if I go down in a parking garage, for instance, and want to write a ticket, it would suck pretty much if I couldn't write the ticket because there's a bad reception in the parking garage. So this is implemented then using client-side, an offline version of this. It looks exactly the same. It has exactly the same functionality. I can add some, write a ticket here, like this. And then I can just save the ticket. Now, of course, the ticket doesn't go to the server because I don't have any connection. So it just marks it here as there's 1 ticket pending. Now, if I was able to get online somehow, we could see that this actually then synchronizes with the server. Let's see what happens. I'm not very hopeful. Okay, so you just have to take my word for it. It will actually synchronize the data to the server, and then the application will continue to work in this online mode, so you have all the tabs available again. So this could be implemented as a client-side application, but it has been implemented server-side just for the reason of the data and the reason that it's much easier to do it on the server side. If you don't take my word for it, go and test the demo here, and you can see that it actually works that way. So let's talk a bit about the hybrid architecture then, or the architecture for a hybrid application. This is basically the architecture for any Vaadin application here. So you have a backend, it's somewhere, it might be on your web server or somewhere else. But then you have the base of the Vaadin application, which is the UI class. So the UI class is what's shown to the end user when they go to this application. The UI class in turn is built up from a component hierarchy, so you add layouts, components, much like you can do in GWT. And these components all have a widget counterpart on the client side. So basically you have the component hierarchy on the server side. This is transferred automatically, or the data about it is transferred to the client side, and there a similar widget hierarchy is built up. And this is then what's displayed to the end user. In addition to this, you have, of course, theme that defines how these widgets look to the end user. But this is like a server-side application. You would do it like this with Vaadin. And now that we want to include the client side, we actually want to add the UI also on the client side here. So we can have something more than just widgets on the client side, something a bit more complex, something larger. But then at the same time, we need to add some kind of service on the server side so the client-side UI can communicate with somebody. So this is basically how we can build up this kind of hybrid application. The service, of course, then connects to the same backend on the server, so we can have interaction between the different parts of the application. So let's look at an example hybrid application that we created a couple of weeks back, I think. So what's the idea here? We have an application, it's a simple address book. You have a table with some address data, you have a form that you can edit the data. The interesting part maybe is the different tabs in this application. So the first tab is server-side, where we've made a server-side implementation of this address book editor. Then we have the client-side using GWT.RPC, now integrated in the same application. So the base application is a Vaadin application. And inside it we have these tabs implemented in different ways. So we have the client-side using GWT.RPC, the client side using Vaadin communication mechanisms, and then we were supposed to have this offline tab, but nobody has actually had time to implement it yet. So that I can't show you today. But basically, we have a really simple backend here, which implements, well, it's based on an address being just contains first name, last name, phone number, email, pretty basic stuff. And then we have a pretty basic CRUD backend, so you can just fetch addresses, update addresses, delete addresses, and create new ones. And backend implementation, it's really a dummy implementation, just basically a big hash map storing the addresses. So let's have a look at how we can implement this if we do it on the server side. So the first tab I had here, a server-side address book editor. Okay, let me just say that we can actually, as we're staying on the server side and we're only doing this one layer, we can get away with making only this one class, which is the actual address book editor. So if you look at some code here, well, the main application, it's a Vaadin UI. It uses a Vaadin servlet that basically listens to everything that happens and reacts to it. And otherwise, this is a very thin UI. It only defines some basic components and then adds a couple of views, the server-side view, client-side with RPC view, and client-side Vaadin view. But if we go down to the server side, we can see that this is the full server-side implementation of this address book editor. So much like any typical GWT application, if you don't use UI binder, you have a lot of components here, some layouts, and the actual editor is roughly divided into 4 parts. So we have the initial setup for adding the components to layout, setting some sizes, making it look the way we want it to look. Let's not go into details in that. We have a method for updating the table containing the addresses. So we have here a reference to the service or the backend, which we actually, in this case, we store it in the HTTP session so we can share it between the different parts of this application. So this basically fetches all addresses from the backend, adds it to a container that is then connected to this table shown on the page. And then we have some click listener event handlers for handling different events in the application. These are pretty basic here, especially on the server side, where we can just, whenever somebody, let's see, clicks, for instance, the delete button, we can just get the value that's selected in the table, call the service directly as a synchronous call, and then just update the address list again, so we have removed the deleted address. And well, the other event listeners, they follow pretty much the same pattern. So it's quite simple code. We have some logic for handling enabled state, so when you are editing something, you don't want to be selecting something in the table at the same time. And then finally, we have the form part where you can edit an address, where basically we just bind the various fields to various parts of this address bean. So we can then use the Vaadin data binding to just, when the user presses save, we can just commit the fields and get the bean updated, and then send it to this backend so it's updated in the backend. And this is more or less the whole application as implemented on the server side. So if you look at it in a browser, it looks like this. So we can basically select something, select edit, change something, his first name for instance, save it, and it will be updated. So it's a pretty simple CRUD editor. Now if we look next on the client-side implementation with RPC, how does this differ from the server-side implementation? Well, on the client side, we also need an address book editor. We need the widgets, we need the same kind of layouts, and the same kind of, well, basically the same kind of everything. So this address book editor will be pretty much the same as the one we have on the server side, except it will use widgets, Vaadin widgets, instead of Vaadin server-side components. But we need some way to get this client-side address book editor now included in our Vaadin application. And as a Vaadin application, it's based on components, so we somehow need to wrap this whole editor in a component. And the parts we need is basically the view part and a connector part. So the idea of the view is basically to place it as a component in the Vaadin component hierarchy. So it then can have its own client-side part, the connector part, which is, well, okay, if you look at from a different point of view, the view part here is in a GWT application would be your index.html file. This is where that defines that well, pretty much here the GWT module should come, and then the connector part here would be your module entry point in GWT. So it defines that we should take this widget and put it on the page, attach it to the root panel, for instance. In Vaadin, we already have the application, we have the UI that has created the index HTML page. We need to implement these as Vaadin components, connectors instead. But the viewer connector basically allows us to just add the address book editor widget inside the Vaadin application. But as the address book editor wants to communicate with the backend using GWT-RPC, we need some way to do that also. So we need to make a standard GWT-RPC service interface with the methods that we need to call on the server. We have the servlet implementation of this service on the server side. We have the async interface that the client side wants to use, and then we have a proxy that implements this async interface. So this way, the address book editor manages then to communicate with the backend through the proxy, the service, and the servlet. So if we look at the code for this, with RPC. So we can see that we have now quite a few more classes here. If we start from the server side, this is our view class. It's extremely simple. It's just something that extends a Vaadin abstract component, makes it a view, and does really nothing else. So it's the placeholder, or tells where the address book editor will actually end up. On the client side, we have a connector class, which defines that this is actually the client side of this address book view we just saw. So whenever we add the address book view class to the component hierarchy on the client side, this is actually what will be called. And the responsibility now of this connector is just to create the correct widget that should be placed in the hierarchy. So it only creates our client-side address book editor. Then we have, well, the RPC interface. It's pretty simple. It's more or less the same backend methods that we have exposed through RPC here, so that the client side is able to request addresses and store addresses and so on. Of course, we have here to define the path to the servlet also that will handle these RPC calls. And then we have the servlet implementation here as a separate servlet, listening to this URL we defined. Basically, all this does is then forward the calls to the backend. Of course, we have some potential security issues here because we don't check anything that comes from the client. This is just part of the demonstration. Don't do this at home. Okay, and then we have the client-side address book editor. It looks pretty much like the server-side address book editor. A lot of fields, a way to get the service reference. The same kind of logic here, initialize the layout, set some sizes for the components. Creating the table requires a bit more configuration here on the client side. And well, the main difference between the client side and the server side here is then that, of course, on the client side we need to use asynchronous callbacks for all these events. So we want to update the address list, we need to make a call to the server, and then whenever that call returns, we can update the address list with whatever it returned. And much the same for all the event handlers. Delete becomes more tricky because we have to take asynchronous callbacks into account. But otherwise, the logic more or less the same. in this version. And also, if we look at this version, it looks more or less the same. The layout is a bit different, but not very much. It could be tweaked to be exactly the same. But we have the same functionality here, with the difference now that this takes place on the client side, and now then when I save it, I'll do the asynchronous callback to the server. But the functionality is more or less the same. Okay, the Vaadin table provides lazy loading. We don't need it for this application, but they're more or less the same. So, what if you look at the complexity of these? Well, it's interesting because the client side, we required 4 classes and 2 interfaces to implement this. In total, something like 500 lines of code. On the server side, we had only 1 class. So actually, in this particular example, we made almost 1/3 of the code for the server-side version compared to the client-side version, or 3 times more on the client side, which pretty well aligns with the assumption that you will have 50% less code when doing it on the server side, as you have fewer layers to worry about. We can do the client side using Vaadin communication also, using the RPC and state mechanisms of Vaadin instead of using the quit RPC mechanisms. So the communication in Vaadin kind of differs from the quit RPC in the sense that with quit RPC you're implementing the servlet yourself and you're communicating from the widget to the servlet. In Vaadin you have these component connector classes which connect the server side to the client side, and the RPCs actually take place between them. But you have also an additional feature in Vaadin that you can use, which is the shared state. So this is automatically synchronized from the server to the client whenever it's updated on the server side. So it's a bit like RPC from the server to the client, or a callback, but not exactly. Also, Vaadin has real RPC from the server to the client, which are not only callbacks, so we can actually invoke something on the client wherever you want. If you look at the architecture diagram, it looks just as complex as with quit RPC. It's just that more or less the arrows go to different places. So we still need the same view and the same connector to get this address book editor into the application. But then instead of having this custom servlet and the service interface, we have 2 RPC interfaces, one for each direction, client to server, server to client. And then we have the shared state for the address book editor, which we can use to send address data. So if we look at the code for this one, there we go. So on the server side, we have made the view a bit more complex here because now we're handling the RPC inside this view instead of in a separate servlet. Basically, the servlet logic has been moved here, more or less, so it's the same methods that can be called by the client. There's one difference, which is that we are also using a state class here. So in the state class, we're actually storing the list of address objects we want to send to the client. So instead of having the client do an RPC to the server to fetch the addresses and then get something back, they are automatically sent whenever this component widget is instantiated. So this makes things slightly easier. On the client side, the connector class, basically the same thing here also. This now deals with RPC calls. We could handle them directly here in the connector. In this example, we forward them to the widget instead, and also create an RPC proxy that the widget can use to communicate with the server-side component. And then we have on the client side also the onState change method, which is invoked now whenever the address list is updated. So whenever we get some new addresses from the server, we just call the widget update address list method and update the contents of the table. The RPC interface is more or less the same as previously, and also this address book editor implementation, it's pretty much the same. We need a couple of callbacks which are here implemented only as server to client RPC, and then we have the same logic for setting this up, setting the table up, and so on. This is pretty much the same thing. You just call RPCs in a different way here. So the question is, why would you do this? Why would you use Vaadin connectors instead of GWT RPC if we're talking about more or less the same complexity here? Well, push is one reason, one advantage of Vaadin connectors compared to GWT RPC, because as Vaadin has the possibility to use server to client RPCs, if we enable server push, we can do this whenever we want. Now, of course, if we're talking about offline, this doesn't make sense because, again, you wouldn't combine offline and push, but it's a clear advantage. But let's say a few words about offline still. So I don't have an implementation to show you about offline. My best guess is that it would be a bit more code. It certainly won't be less code to do the offline mode. So as I said earlier, we need to start from a client-side UI. We can't make server-side UI offline. So we need to have a client-side UI. Then we would need to add some offline detection. We need to know when we're offline, when we're online. We need some way to bootstrap this offline application. So this requires even some more logic. And well, maybe the trickiest part then is we need to handle data in offline in a different way than when we're online. So we need to have a local storage database. We need to store the data temporarily there, like we can store the parking tickets, so that we can then synchronize the data with the server whenever we get online again. Now, with offline, this data synchronization can be the most tricky part in many cases. In the parking ticket application, it's very easy because you can just add new data and it's just adding it on the server side database. But in more interactive applications, you can have real issues here when you want to merge the offline data from several users and you don't really know what happened. So of course there are different ways of solving this, storing modification logs, for instance, just replaying them and hoping for the best, or whatever you want to do. This is basically always application specific, so there's no generic solution for this. You just have to code it somehow into your offline support. And also, when you have a lot of data, you can't send everything to the client, so you need to split up the data somehow and decide what to send to the client, what to not send to the client. So let's make an assumption here. We need double the client-side code to actually implement this. This is just a best guess, as I don't have the implementation even for this one view right now. But if we say that we need double the client-side code to do this, and we take into account the earlier one where we saw that we need 2 to 3 times the client-side code to implement the same as we do on the server side, we get to the conclusion that actually if we compare an offline view with a server-side view, we are putting like 5 or 6 times more effort into making this offline view than making a server-side view of the same thing. Well, the logical conclusion of this is, of course, don't make offline if you need offline, because during the same time you make one offline view, you can make 6 online views or server-side views. So you can save a lot of time there. So let's talk about cars. We have the client-side car, the Mercedes. You have full control and you are really ready to go offline because you already have implemented all the 3 layers. You only need to double the complexity here to get it offline. On the other end, we have the server side. You have implemented the least amount of code. You just implemented 1 layer, but now you need the connection to the server, always. So you will have a really hard time of going offline. But in between, we have the hybrid applications then, which is pretty nice because here you can select then that for this view I want to have offline capability and I want to put more resources into these offline views. But for these other views, which really can't be used offline, it makes no sense to even do them on the client side because there might be some administrative views that somebody in the office uses and they have a good connection and they don't have any problem with this. So you have quite a lot of more flexibility if you choose this hybrid approach. Actually, I think I'll pretty much end here. Which should you use? That's up to you. There are certainly cases where the client side is good. There are certainly cases where the server side is good. Hybrid is something that really not many people that I know of are using at the moment, but I'm sure it could be used a lot more, especially when you have the use cases that you really need offline only for a small part of your application. So, just a few slides about Vaadin. If you want to know more about Vaadin, grab the book out there. I'm sure many of you have already done that. And I just want to mention also that Vaadin is not the evil commercial framework. It's an Apache 2 license, so you can do just anything you want with that. It also has a large community and so on. But are there any questions?
The server-side approach, can you have client-side validation for some part of your flow, or is everything validated on server-side?
Yeah, so the question was if you can use client-side validation when you do your server-side UI. And the answer is, if you're using Vaadin today, there's no built-in support for this. People have made add-ons that enable you to do client-side validation by just specifying the validators on the server side. So then you get a faster response to the user, of course. But no, not out of the box, yes, using an add-on.
Just to continue the question, can you have an event bus client-side? Or you always have to use...
Sorry, just to continue the question, can you have an event bus client side, or you must always have to use the server side notification mechanism?
So if you do a hybrid application, of course you can have an event bus on the client side and handle events as much as you want on the client side. If you do a server side application, by definition all the events go to the server and are handled there. Did this answer your question?
Yes.
Good.
It's simply thinking of a migration path from a pure GWT application where everything happens the traditional way to something Vaadin.
Yeah. So I actually haven't done any of these migrations myself, but it should be, you should be able to migrate or kind of start by wrapping your GWT application in a Vaadin application, just making like one view, one connector for the whole GWT application. And that's the first step. Then you have it inside Vaadin, and then you could start moving towards a hybrid application if you want to go in that direction. So just pick parts of the GWT application and move them to the server side.
Is it possible to make the other, the opposite, the other side? I have a GWT application, and I want to migrate to Vaadin, but gradually.
Yeah, so you, instead of integrating GWT into Vaadin, you want to integrate Vaadin into GWT.
Yes.
Yeah, that should be possible. It's not as straightforward as, well, Vaadin uses GWT today. That makes it pretty simple to integrate in that direction. If you integrate in the other direction, well, you have a couple of options. You always have the iframe options, which is typically not so nice. But if you want to you have your views in your GWT application and want to add a Vaadin view there, you could just basically add the bootstrapping code for Vaadin UI into your GWT application and deploy the Vaadin servlet and make the server-side UI there, and you should be able to then get it into your GWT application.
Is there any example somewhere in the website?
I'm not aware of any examples of this, but there are examples on how you can embed Vaadin into existing web pages and like JASP and things like this. So it should be basically the same thing.
Thank you.
Yeah, we are currently using a lot of UI binder, and I was wondering if there's another similar thing to build Vaadin widgets.
Yeah,
Since you always build from this Java stuff, which we don't like too much.
Yeah, currently there's no built-in support for declarative UIs, but the answer is basically the same as for client-side validation. There's an add-on for that.
Okay.
Actually, one of our employees has made a really nice add-on where you can specify the layout in a declarative way using XML instead of using Java.
Okay, cool, thanks.
Do you have any plan for supporting ARIA?
ARIA support. Yes, we're actually working on that at the moment. Some of our components already support ARIA. Currently, we're working mostly on getting the new grid to support ARIA, and I would say today most of our fields support ARIA. Basic components support ARIA. The more advanced components, there we still have some work to do. Sorry?
Also tables?
Yeah, so the new grid will replace the table.
You showed us that one part of the application is server-side and the other is client-side. Is there a possibility to share the business logic on client-side and server-side? So it's real hybrid.
Yeah, that's a good question. I mean, you're able to share code between the client and the server side. With typically when you make, well, I would guess it depends on how you make your business logic. If you make on the something on the server side like directly depends on your database entities and so on, it will be pretty hard to move this to the client side. But on the other hand, if you have let's say if you have code that you can compile using the GWT compiler, you can always share the code between the client and the server by just putting it in the shared package so it will be available to both sides. But I really don't have any examples of how you should do this in practice. Okay, so I'm apparently out of time here, so if you have more questions, please talk to me afterwards. Thank you.